Chapter 3, exercise 3. Oh yeah, these are nice. Oops. So isn't it 2 pi? 31 is pretty much 2 pi. Chain rule. minus 3 minus square root of x. One over 2x. Yeah. Hello. Hey, James. Can you hear me?
Hello.
Yo, hey. How you doing?
Hey. Good. How about you?
Pretty good. All right.
Cool.
How's your Saturday going?
Good.
Okay. Yeah. So like I was looking at a few things yesterday, like chapter 2 and 3.
Mhm.
And then like for chapter 2, well, it seems like there's not much related problems from like the homeworks. Like the homeworks that you guys were given.
Yeah.
Yeah. And or like the quizzes, yeah. Like, and then I was like, oh, maybe we'll just do some chapter 3 like speed drills. Or did you have any other questions from last time?
Yeah. I was just gonna tell you that me and my roommate did the chapter 4 homework yesterday,
Okay.
and it took us like 2.5 hours. So it was.
Oh wow.
Yeah. It was. That one was
What's
actually
chapter
pretty
4?
cool. It's like local max and mins, and then it was like a lot of stuff about optimization.
Oh, you guys are applying it already?
Yeah. So like optimization is pretty hard. Our teacher showed us an example, but
Okay. Is
pretty
that
hard.
gonna be in the midterm?
Yeah, definitely. He showed us an example in class, so.
Okay. I know how to do that. If you want to share your screen.
Cool.
If you guys have like a few like is there like a PDF of the file?
No.
Okay.
I have it on my homework actually though. I can just pull that up.
Okay.
That works for you, yeah. I also got onto Frog Tutoring.
Okay.
I'm on the site if you want to try. I think I'm logged in, yeah.
Okay, let me see. I was gonna like for Because I was wondering if you wanted to do a Zoom, but you still want to do a Zoom, right?
Yeah, I'm cool if you want to. I'm cool with whatever.
Usually, like, I just let it go. Here, let me see if I can.
Yeah.
Yeah, let me know if you what problem you want to do, because yeah, I didn't know that you wanted to do something that's related to optimization, but we'll talk about it. I can let you know, because it's really easy. It's just applying the things that we've already learned.
Cool. Yeah, those problems though that you had up, like I probably honestly just want to take a. Were those just in the book?
These are just some that I found that maybe help us. Like, I know we were doing some quotient rule stuff, and these are chapter 3 stuff. But
yeah,
like,
that would.
I feel like maybe we should do like word problems.
Yeah, that's what's going to be on the test. But doing this would also help me a lot too. I think like all those problems. Just to practice. Yeah, I should probably do that.
But let's attack the one that you guys were struggling first with.
Okay. I'm pulling up the homework right now. Here we go.
Okay.
So I got it right, but it took me a while. Like.
That's fine. We'll hash it out. There's like other. So which one is this? Is this local minima, maxima, or the
Oh, it says I can't screen share while you're screen sharing.
Yeah. Here, hold up first.
Cool.
Go ahead.
All right.
And I'll try to see if there's a problem here that we can probably do.
So this is our homework.
Okay.
And this was pretty hard for me. Like it took me like 30 minutes, which is not good.
Yeah. Let's read it first. Cruise line, the number of it's pretty much just like optimize. This is an optimization problem. One number of passengers maximizes, right? Yeah, it's an optimization problem. The number of passengers to maximize the cruise line revenue is 145. Let me see. How's the trip for? If at least 100% of the price is reduced for every, the boat can accommodate to the number of passengers maximize the cruise line. So you have to create an equation and then kind of just like, for A, I believe. For these problems, you have to translate the word problem to like some equation that you can take a derivative of.
Okay.
That's really like how I would attack it. But then like the harder part is probably translating.
Mm-hmm.
The word problem to like an equation.
Yeah.
Equation.
Let me just see really quick. Yeah, this was another optimization problem too. Number 10.
Okay. Plans to enclose.
Oh, sure. Let's go back. My bad.
Yeah. Let's try to look at this one. A landscaper closest to the enclosure. She will use the 25 per foot. Find the minimal cost. Okay.
So this was basically the exact same to the one we did in class.
Okay. So like for these ones, I found something that can help us out. So for this one, like what I would do is kind of like set up the problem. So like you're given like 3,000 square foot, right?
Yeah.
Like that's like an area.
Mm-hmm.
And like my first bet here is like maybe create some variables like A equals 3,000 square feet, and then this is asking you it's giving you like a rectangular region. So maybe like A equals like A times B or X times Y, and that's 3,000.
That's exactly what we did. Yeah.
Okay, but like it's just the system of it. Like you gotta have to pay attention to the wording.
Yeah.
So that's what I would do, and then so for Y, maybe like
and
X
then we did we found out the area, and then we did a cost function.
Yeah, it just kind of reminds me of like, do you remember in algebra, you had to do a system of equations, and
yeah.
But this is the calculus counterpart.
God. Yeah.
Yeah. So I think what I would do first is like maybe a equals xy, and then did you guys do that? What's the next thing you guys did?
So yeah, we did the area and then the cost function we got. So for this problem, it would be 2 times 25x plus 20y plus 25y.
Okay.
So yeah, that's what we did. And then we solved, in that equation, we solved for y.
Okay.
So then we got y equals 3,000 over x.
Yep, that's right. Yeah.
And then you can like solve the x, because you just plug in the x for y, 3,000 over x for y.
Okay.
And then you put it into the equation, so then you can get x. And then once we got the x value, or the root, we put it in a variation table of the derivative.
What do you mean by that one? Like, so you actually create a table?
Yeah, like a sign table thing. Yeah.
Okay. I would probably like, let me see if I can. Like, I would probably just create the equation, the cost like equation, and then take like a derivative.
Okay, it's because he wanted us to show, or he wanted us to find the global min.
Yeah. So what I would do is you have to test the second derivative for the global min.
Second derivative?
Yeah. That's how I would attack it, because then like the min would be once you take the second derivative, right, of the cost function, then like if it's greater than 0, then at that point, like when you have x equals that point, that's like the absolute minimum.
Okay.
Yeah, but you could probably create a table. So what did you guys do after that one?
The next problem.
Yeah.
After that we did, this one was really weird for me.
Okay.
It was like a super long word problem. I can just read it to you. It's about buying a car with 1-year warranty, and you consider buying an extended warranty for $375 covering damages for 2 years after the first year. Estimate that yearly expenses will be $150 at the end of the first year of the extended warranty and $250 at the end of the second year. We assume an interest rate of 5% per year. Should we buy the warranty?
That's a weird one. Like let me look at the. Is this another optimization one?
Yeah, it's kind of optimization again, I think.
Okay. Do you have like? Is this just from a book? It was hard to like. Let me see if I can. Standard. Did he solve this for you guys?
Yeah, he did. He solved it. And I don't know where he got it from, because it's just an example he gave us during class.
Okay.
But he was talking about like present value and future value, basically.
Oh, okay. Then those are equations that you can solve for like if you're given the equation, you can just like take the derivative of this.
Yeah.
So you have those, and then what do you do? What did you do?
So I was pretty confused on this one.
Okay.
Just because of the wording of the problem, honestly.
Yeah, if I can like, can you read it again, like slowly, like so I can like see what is like asking.
Yeah. It's pretty badly worded. Sorry. Like, yeah.
It's all good.
You consider buying an extended warranty for $375 covering damages for 2 years after the first year.
Okay.
So that's the first part. Estimate that yearly expenses will be $150 at the end of the first year of the extended warranty and $250 at the end of the second year.
Okay. I think I got something. So you have to estimate the yearly expenses, right?
Mm-hmm.
Somehow. Let's see.
So yeah, this is.
Oh, I think I got it. So for this one, so here's kind of like a similar problem, but let me know if it's not similar, because then I can explain this one.
Okay.
Like you're buying a car that comes with 1 year warranty and considering whether to purchase an extended warranty, right? This is the problem. Whether to purchase an extended warranty for like a price, and then the extended warranty covers like, maybe 2 or 3 years after 1 year, right?
Mm-hmm.
And then does it give you the interest rate?
Yeah, 0.5 or 5%.
And how much was the extended warranty?
$375.
Okay. Oh, he got this from the 4th edition, I think.
That's hilarious.
Yeah, it's exactly. And he said that so you estimate the yearly expenses that would have been covered by the extended warranty are 150 at the end of the first year. Is that the one? 150 at the end of the first year?
Mm-hmm.
Yeah. let me see if so like, what was the first thing he did?
He said step 1, buying the warranty, present value equals 375. 2, estimate of repair expenses. At the end of the first year, in 2 years from now, the extended warranty, and then he set up 2 equations.
Okay.
PV1 of E raised to the 0.05 times 2. And then he got PV1 equals 150 E to the negative 0.05 times 2.
Yeah, I would probably do that. Let me break it down. Like, let me see if I can.
Yeah, and then the second equation is just PV2 equals 250 E to the negative 0.05 times 3.
Number. Okay. Okay, I think I got this. Okay, so and what was his answer? The future value? Is it 369? Something like that?
369?
What was the future value?
Overall, like the very end thing we got was PV of the estimated cost to repair equals the 2 equations added together, and then the final answer was $350.90.
And then did he say not buy the extended warranty?
Yeah, you shouldn't buy the extended warranty, exactly.
Because it's less than 375.
Yeah.
Yeah. Yeah, so like I would probably set up like 150.
Mm-hmm.
And then you make that like maybe, because you're just pretty much comparing the the extended warranty. And if you get something less than that for the future value, then like you shouldn't buy it, because then it's more expensive.
I was just a little confused on how he set up the equations, but
yeah, it's actually, there's an easier way. Like what I would do here is maybe just do 150 over like 1.05, and then plus 250. This is just you looking at the future value. And then 250 divided by like 1.05, like the interest rate. Plus zero, like the interest rate. Oh, and then this is for the 2 year one. So 250 over 1.05 squared. And then that value, that future value, compare it to 375. And if it's less than, then you don't buy it. If it's greater than, then you buy it. That's how I would attack that one.
Okay.
The way, like, it seems like he did more. Like, it seems like he did more than
Yeah, we kind of did. I can show you it if you want.
Okay. Let me see if I can see it.
Yeah, those are the equations right there.
Okay. 150. That's the future value, and then present value. E. Yeah, that's you could do that, like E to then 0.2 and then 250.
Yeah.
And then he got 350, right?
Yeah, at the bottom.
Yeah. And then you compare it to 375, which is less than. The theory, I would attack it the same way. And then you just apply those. So like, I guess the concept there is apply the future value, and then and then if it's less than, then you buy it, or you don't buy it.
Yeah. Okay.
Yeah.
Cool.
What part of that doesn't make sense?
it was just kind of setting up the equations for me, like.
Okay. Is that your guys' future value equation with the exponent?
Yeah.
I remember it like as like, was it present value equals like 1 plus the interest rate, right? To the
I'm not
future value equation. Yeah, the future value equation is like present value 1 plus the interest rate to the n, right? Isn't it?
Yeah, that's what it is. Yeah. So we multiplied it by the interest rate and then by the amount of years. Yeah.
Well, why is he using like the exponent, like e, exponential?
I think because he says it's an inflation rate
Continuous?
and he said it's compounded continuously too, I think.
Okay. If it's compounded, yeah, you use that one instead of like the 1 plus.
My bad. He just put that in parentheses at the very end, like.
Okay.
Yeah.
Yeah, it's just pretty much like applying that equation and then like adding the two.
Okay.
So he could probably change that for you by like changing the cost of each one and then giving you a different interest rate.
Okay, yeah.
But the system, the procedure is pretty much the same.
Yeah. So the next one we did was this. So basically, the next yesterday during class and then Monday and Tuesday during class is just going to be all review for the midterm. So.
Okay.
Like.
So for the optimization problems, did you want to do more of those or like local minimum?
Yeah. Probably some practice ones would be good with those.
Okay. Is there one that is there like a homework problem? Like maybe we can take a look at the homework problems again.
Yeah.
Or maybe just like talk about it.
So this one is a homework problem, but I already did it.
Okay.
This one was pretty tough though. This homework problem took so long. So.
This is a quiz line offer for at least one of us sign up. Let's take a look at it. So. Okay. Okay, so for this one, okay, I think I got it. You just have to apply the revenue equation.
Yeah, so I have all the work for a lot of it right here. Yeah.
Let me see.
I was just did this out when I was doing it myself. the revenue equations right there.
Yeah. So like he gives you like the 1900 per passenger. So I would like you always want to set up the revenue equation here.
Yeah.
It's like P profit, 1900 minus what is this one? $10 for every additional passenger beyond 100, right?
Mm.
So that would be like the 1900 would be like your main, and then you minus 10 for every additional. It says that the price is reduced for all the passengers, so that's minus 10 reduced by 10. But then this 10 only applies beyond 100, so it's like passenger minus 100.
Yep, that's exactly what I wrote.
Okay, and then like after you have that equation, so I guess did you get like minus 10p squared, p being like the passenger, plus 2900 times p?
Yeah.
Yeah, and then what does it say? So it's asking the number of passengers that maximize the cruise line's total revenue. So then you take like since it's asking you to maximize it, you optimize any either minimum or maximum. You just do like you take the derivative of that equation.
Yep, that's what I did.
Okay.
And then I set it equal to 0 and then solve for n. Yeah.
And yeah, or p. Yeah. Okay. And then did you get what did you get? Did you get 145 for p?
Yeah.
The number of passengers that maximizes. And then like so for passengers it's like 145.
Yeah.
And then like for that one, like it's asking you the price of the passengers pay. The passengers pay is you just plug that back into that the 2900 minus 20 times the passenger, so that's like, and then you got what
1700 or no, that was for the second part, sorry, 1450.
Yeah, that makes sense. That's pretty much how you set up the equation. Like the equation is pretty much given in like the first sentence.
Yeah.
And then like since it's asking for maximum, you just take the derivative. And then like the number, but then every time it's asking what is the passenger pay at that maximizes it, you just plug that like the variable that you found after taking the derivative, setting that to 0, and inputting that in that derivative, and it'll give you the revenue at that maximum.
Okay. Yeah, I think I got it better now.
Yeah, it's like you just have to talk about it. Like it's really like just like what equation or how you set it up, and then like solving for what variables.
Yeah.
Okay, what about for B?
For B.
Let me read this on.
Yeah.
Cost of the cruise line for number of passenger and that's the cost, 80,000 plus 500 and. So I guess the profit here would be because that's the cost, right?
Yeah.
So that's the revenue minus the cost is the profit.
Mm-hmm.
So you already have the profit, or not the revenue. So and then you just minus that equation that he gives it to you. So like I would think it's like it's like minus 10. The passenger squared plus 2900 times the passenger minus the equation he gives you. Did you do that?
For part B, I was pretty lost on this part, so I just like looked at a problem that was the exact same and how they did it.
Okay, what is it? What is this one asking? Let me see. The maximum profit that the cruise line can make on one trip.
Yeah. So that's what you do. You end up doing the total revenue minus the total cost.
Yeah, this is kind of like A. Like it's exactly the same, but then instead of revenue, it's like the profit now.
Mm-hmm. So I said 2900 minus 20n equal to 500.
500?
Yeah, because that's the derivative of the second of the cost function.
Minus b minus 1. Okay, and then what did you get for that first part, the maximum profit?
First I got that the amount of passengers was 120.
Okay.
And then for the profit, I just plugged in 120 to both equations. Or wait.
Yeah, that's correct. Okay.
Yeah, that's what I did. Yeah. So then I got 200.
You got what?
I just plugged them in, and then I got 204,000 minus 140,000.
204,000. And what was the final?
64,000.
For the profit, the maximum profit.
Yeah, 64,000.
Yep. Yeah, that's the answer. And then like the other one was I think 17. There's another square. The number of passengers that must sign up for the maximum coverage is each passenger must pay. Is that 120? I think that's 120. That's 120, and each passenger must pay 1,700. And then the profit is 64,000. Mm-hmm. Yeah, 64,000. And then you got 120, and each one is 1,700, right?
Yeah.
Yeah. Does that make sense?
Yeah, it's making more sense now that we went over it. Yeah, I'm pretty clear on everything actually.
Okay, that's good. Yeah. Like these optimization ones, like it's really just like whatever we talked about. If you were to practice this for this, I couldn't find a problem like this on the book. Maybe it's in a different chapter.
Yeah, this one's from chapter 4, I think.
This is chapter 4. Okay, let me.
So that's what we were doing today, or yesterday. I mean, in class.
Okay. Did you want to do more of these, or do you guys have other is the local minimum maxima is that just applying it? This is technically what we're doing.
Yeah, exactly. This is all helping with it. For those, it's basically he just wants us to do a table every time, sign table, or whatever.
Oh, okay.
Do you think you can do you mind sharing your screen really quick one more time with that worksheet?
With the other stuff? Okay.
Yeah, I'm just gonna copy that worksheet really quick if that's okay.
Okay.
Thanks.
So you're good with word problems, right? For now.
Yeah.
Let's maybe we can here's the stuff I have.
I mean, the thing is though, I think it's gonna be entirely word problems on the test, or mainly word problems at least.
In the exam?
Yeah.
Did he say that?
But that's how all our quizzes have been, and he said it's going to be the exact same.
Okay. So you should practice it. So there won't be any just math part, right?
Mhm.
Yeah. A lot of chapter 3 were just the basics of knowing these rules. And then are you strong? We didn't really cover it, but you're good with limits, taking limits, and then the old definition of a derivative.
Yeah, I'm decent. He gave us an example. Actually, that was the last example he gave us in class, was using the definition of a derivative. Like
the FA plus H, that one limit.
Yeah, but he used the function 1 over x. So it was actually really easy because it's so simple,
Yeah. Okay.
But during a test, he'll use a way harder one and then probably get screwed.
Okay. Yeah. Yeah, I think you're strong with the derivatives already. I remember we did that the other time.
Mm-hmm.
And then what are you guys gonna be doing in the next week or so? Is it just gonna be the rest of chapter 4? And are you guys moving to chapter 5?
He already finished chapter 4. Apparently,
okay.
I think he did that chapter literally in one day, the entire thing. Because now we're just reviewing. So Monday and Tuesday, we're just going to be doing more review problems like these.
Okay. Yeah. I think for and then your test is when? When is it Wednesday?
Yeah.
Okay. How confident are you with like everything? I think the other time we kind of just we went over like a few of the the derivatives, and now we went over like word problems. Do you think you feel comfortable with all the stuff in this exam?
I mean, I just know how it's so fast. That's the main thing for me.
Yeah. Were you able to download that like Wolfram Alpha or like sign up for it?
Yeah, I didn't buy the pro or anything.
Okay.
But I still like oh, my friend actually, my roommate.
Yep.
Found another site.
What is that?
I forgot what it's called. It started with an S.
Oh, an S. I wouldn't know. Like, okay. What about it though?
Sorry, I'd ask him, but he's sleeping right now.
Yeah, it's all good.
So that actually went step by step. Like it showed you the thing step by step, and it didn't even make you pay for anything.
It didn't make you pay?
Yeah.
Which one is that one? That's the better one.
Yeah, I know. I'm not sure. It started with an S. I'm gonna ask him when he wakes up.
Definitely, yeah. Even I would like to know too. That would really help me out. Share it with everyone.
I'll text you it when he tells me.
Okay. Okay. So it seems okay. So like for like Monday, maybe if you like next week, if there's things that you feel uncomfortable still, just like reach out to me, and then maybe like before your exam, I can just like let you know, or we can run through like things that are still unclear.
Yeah,
but
cool. I think like Monday and Tuesday we could probably, if anything, meet both days, or maybe just one, but like to cover the last couple review problems that we do in class.
Okay. I was just looking at like chapter 4 and 5. So you said your professor is done with 4, right? You said. Yeah,
but we're not. The test isn't going to be on 5 at all because we haven't gone over it. I don't think.
For this class, is it like it's not just calculus 1, it's applied calculus, right?
Yeah.
Because I was wondering if this class was gonna like I'm thinking you guys will cover integrals, because that's like the next few chapters.
Yeah, we're definitely gonna do integrals. I saw that in the next chapter.
This is just me. I'm just thinking ahead, like what we should do. There's a lot of stuff we can like. I guess what we can split it, like we can talk about like the math stuff, and then like applications, like for next couple weeks.
Mm-hmm.
Okay. All right, James. Yeah, I think that sounds good for me.
Cool. Yeah. All right, I just saved that worksheet, so thank you.
All right, man. Good luck, and then let me know if there's anything else.
All right, cool. Thank you.
All right, cool.
See ya.